Hello viewers, this is Katsis coming up with another video. This time it's about spreadsheet workbench in Freecad. You must have used Microsoft Excel spreadsheet or Google Sheets before. There are many others as well. Spreadsheets are primarily used for data manipulation, statistical analysis, or graphing. In Freecad, spreadsheet workbench can be used in variety of ways. I'm going to walk through basic to advanced features of spreadsheet in Freecad, where I will couple a simple parametric model dimensions to a spreadsheet and then solve an engineering design problem by model iterations. So let's start with creating a model. So I'm going to create a new model. Now I can save this model. Let's say I'm going to save it as a bench stool. So we'll start with the say the sketcher. I'm going to use the XY plane. Now first thing is I'm going to create the stool legs. Okay, so we'll start with a cross section of this leg. So I'm going to have like a square, then I'm going to have another square, and so we'll need to put some constraints around this. Okay, so let's do the same thing to the other one. Okay, so going to put some dimensions around it, and the way I dimension is there's a good reason why the way I dimension this section. Okay, and then I'm going to give a thickness to this section. Okay, so that pretty much constrain this section. So you can see I'm not going to worry about these dimensions yet, okay, because we are going to handle all these dimensions in our spreadsheet. So close the sketch, and then you can see this section. Now I'm going to go and open the spreadsheet. So the spreadsheet is you have various options, but first thing is you have to start create a spreadsheet. Okay, start with creating a spreadsheet. Now this spreadsheet, you can give a name. I mean, it's currently default is spreadsheet, but you can say you can put a name on it, or you can have multiple spreadsheets. Either way it's fine, it'll work. Now, so I'm going to, since I created the model, I'm going to put some dimensions. So I'm going to name them first. So I'm going to say thickness, width, height, etc. And I can give some values here. The thickness is, let's say, I'm going to put some values here as a starting point, 0.25, and then 1, and let's say 1.5. Now now you, by default, these dimensions are all in millimeters. Even though I want to work in inches, when you get to the spreadsheet, everything is in millimeters. So that's a bit of a problem if you want to use different units. Okay, now one way to do this is to go to properties, go to display units and type inch. I mean just in. Okay, that will convert whatever the unit you have here into inches. Okay, so this I have it as a 1 millimeter here. Now if I go and properties and put in means inch, it is get converted to inches. So same thing here, you can do by putting in here. Okay, now so every time when you want to work in inches, you have to type in. Okay, now how do we assign each one, what the properties are? So first thing you have to do is, now you have assigned the units, I want to assign an alias to that. So let's say thickness, I'm going to say thickness. It can be any name. Okay, it could be just T letter or a couple of letters to identify it. Okay, and I'm going to say here to the alias, I'm going to put as WITTH1. Okay, and so now when you give a alias, it get highlighted in yellow. Okay, that means it has a alias defined to that dimension. That's what it means. Okay, so let's say HITHT1. Okay, so I'm going to, since I made some these are very small dimensions, I don't want to deal with that, so I'm going to go back and change. Now every time you type a dimension or a value, you have to type in to make it inch. Okay, so here 1 inch. I have defined number of decimal places, that's why it show up as multiple numbers, but multiple decimal places, but that's all right. It's not a big deal. Okay, so you have defined your dimensions in thickness. Now how do we assign these values into your model? Now the way to do that is to go to the spreadsheet, or not to the spreadsheet, to the model, and you can see I have defined number of dimensions. So my thickness is this value, and I want to maintain a uniform thickness across it. So what I'm going to do is go right click it, or actually double click it, and go to this formula, and now you have a value. Instead of doing that, you type spreadsheet. Okay, so it will pick this spreadsheet because you have a spreadsheet already defined in this model. It will give you the option to pick that spreadsheet. Okay, so you pick that spreadsheet, and then I'm going to type th. It will give you all the variables that you have assigned. Okay, so I want to assign the thickness, so I'm going to assign thickness. So spreadsheet dot thickness is what you got. Okay, now you say okay, it is, you see that value changed to 0.25 because that's what I had in the spreadsheet. Okay, so likewise you can go and define your dimensions and associate that with the spreadsheet. Okay, now here once again spreadsheet, pick the spreadsheet, say height HEI, whatever that is, I give you the variable to pick it, say okay, it is 1.2 now. And also you can notice your colors of these dimensions in this sketcher has changed, because now it is driven by a spreadsheet rather than you actually driving it through the sketcher itself. Okay, so I would have to, because I want to save the same values is the thickness. I have to change this one as well. Spreadsheet, it's again thickness. Say okay, say okay. Now this is the width, so let's see spreadsheet and width. Okay, my cursor is not somehow picking it up correctly. So you got some values you have defined here. Let's go back to the spreadsheet and play it around with this a little bit. So I'm going to say now it's going to be, rather than 1 inch, I'm going to say 1.1 inch. Okay, and I want to change the thickness a little bit. So I'm going to say 0.3 inch is that. Okay, now let's see, go and see what happens. Okay, now of course what I forgot to do is to close this sketch. Okay, so that's what the problem was, it did not get updated. So let's go back to the spreadsheet, see what your values are. 0.3, 1.1, 1.2. Now go back to the sketcher and see what happens. So that got updated. So while you are in the sketch, it won't get updated, but once you close it and open it, it will get updated. Okay, now so once you have this, so that's kind of a initial introduction how to use spreadsheet to drive your dimensions, and we can do more with the spreadsheets. Okay, now I need to expand this section to create the bench stool leg. Okay, so I'm going to create another sketch. So I need to go back to the part design workbench and create a new sketch. This time I'm going to create this sketch in YZ plane. Okay, say okay. Now it rotated to my YZ plane. Let's create the path for that. So we'll start with a simple line, pick the center. Let's see, let's give us some dimension. Okay, some length to that. I'm going to create some arbitrary line here. Okay, a couple of arbitrary lines, and then need to create an arc, center and radius. I'm going to pick approximately the points I want to create, so I'm going to pick this guy. So now it created the path I want to drag this section. So put the tangency constraint here between these two lines. Okay, so you have the tangency constraint. Okay, and now what you could do is put some dimensions here. Okay, so let's see, 10 inch. So that created that 10 inch, and I need another constraint, so I need to put another maybe radii here, radii. So I think I need more than that. Let's say 10. Okay, so you got 10 inch height and then 10 inch radii. That should work. Okay, and we can change it if we need to change it later. That's fully constrained. Now you can get out of the sketch. So you have this path I created. So what I need to do is to sweep it across, create a section. Okay, now I'm going to use the sweep option. I will first pick on the sketch that I want to sweep and say I want to sweep across, and then so I can see what the path that I need to select. Okay, so you can say add edge, click on the add edge and start picking your edge you want to sweep across. So add edge again, now add edge again and select. So that create your section. Okay, get out of it. I've got a section, a decent size section that I can change it later. Okay, don't worry about it, but now for now this is what I want. Okay, now I want to play with my spreadsheet, so I'm going to go back to my spreadsheet. Now of course we created the initial dimensions. Now let's see what else we can do with the spreadsheet. So now you have this width and the height, which is the inner square that we draw, right? Now I want to give some dimension to the outer as well. So I'm going to say outer width and say outer height. Okay, now it's obvious that the width, inner width plus 2 times the thickness is the outer width, right? So can we put a formula into our spreadsheet? Now Excel spreadsheet, everybody knows that that's what you do, but in a Freecad, can we do that? Yes, we can do that. Now how do we do that? We go and click on the cell and press the equal button. Okay, press the equal button and then start entering a formula, right? Now I say width is my B3, so we'll start with the B3, so you can pick it or you can type it, either way is fine, and then type the plus sign and then do the 2 times the thickness, 2 times the thickness, which is B, once again 2, and then press enter. So that automatically get converted into units. You don't have to put the units sign here. It is because it knows that this is in inches, it automatically put this. So same thing you can do here for the height as well. Start with equal sign, B4 plus B2 times 2 give you, so you can see that, right? That's the right numbers. Okay, so that is one thing you can do with the spreadsheet. So let's see whether we can calculate an area for this section. So we'll type area here, and then I'm going to calculate the area. Now how do you calculate the area? You have the outer width and the outer height. You multiply these two and subtract these two of the multiplication will give you the area, right? So let's try this. Equal sign and B7, which is the outer height, multiplied by the outer width, which is B6, minus these two, which is B4 multiplied by B3, and just enter. Yeah, just enter. Okay, so what happened was it actually knew that you are calculating an area. Therefore what it did was it put inch squared as an area. Okay, so that's clever, right? I mean, you don't have to put the units here. It already knew what the units are, so it is going to put the units, appropriate units, into the cell. So the next thing I want to do is to put a beam in between this top and the bottom surface, supporting the structure. So when you load it up from the top, there is a beam that can carry that load. Okay, so and then the same time that beam should have the same section. Okay, so when I vary this section of this beam also should vary. Okay, so how do we do that? So there's, you know, there are maybe a couple of ways of doing that, but let's try a simple way of, you know, creating a binder or shape binder and see what happens. Okay, so I'm going to click on this face, and then, oh, first of all, let me back it up. I'm going to create a new body because this beam is a separate body, and then pick this face and then ask to create a binding surface. So I created the shape binder. Now if you are kind of not familiar with the shape binder, there are a couple of tutorials. Actually there are 3 tutorials that will walk you through what is the shape binder, how to use it, what advantages that has. All that is described in my prior videos. I will put a link to that, to those videos, so you can go and watch them. So now once I have created this shape binder, what I can do is I can position it. Let's say I want to position it. I'm going to transform this guy. Let's move it here, and then I want to, since I want to create this beam, I want to rotate it such a way that it is parallel to this face, then drag it up to align it, then you have to be sure that you're aligning it properly. So I'm not going to align it exactly, but I just want to prove a point here. So let me go, and so now it seems like it's aligned properly. So I'm going to give what I'm going to do is I'm going to use the shape binder and try to pad this guy. Okay, now I have this much length, but I need a little bit more than that. So let's say 18.2. I know what the length I need to be, so that this kind of a you know, support, this kind of act as a supporting structure. Okay, now, so okay, this looks good, everything looks good, but let's see what happens if I change these dimensions, because I'm doing like a parametric model. I'm using a spreadsheet to control the dimensions. So let's see what happens if I change few things. I'm not changing much, but I'm changing enough to cause a problem. Okay, maybe I didn't. Okay, let's say 1.4 inch. So you can change. Still change. I don't know why that didn't happen. Okay, this time it worked. Okay, so 1.4. Change it to, actually it's not change either, so I'm gonna go and change it to 0.4 inch. Okay, so I change these two and see what happens in the model. So yeah, it got kind of a screwed up, right? Because my section, because it tried to take the shape of the same section as this guy, and but now it's skewed, it's not aligned properly, and it has increased its length as well. Now it's kind of going into this leg that I created, right? So this is not good, right? Now there are ways for us to do it in CAD. You may have to put some constraints around it. There are a lot of things that you have to do to make it work, so that this, whenever I change these dimensions of this section change appropriately. So you can do it with CAD, but you know, it's going to take a lot of time, and you might have to spend a lot of effort to get it done correctly. So but there's an easy way to do this using spreadsheet. So I'm going to show that how to do that. So let me delete this guy again, because that's not useful for us. And now I'm going to approach a different method that I can utilize to do the same thing but effectively. Now I'm going to create that body again. Okay, so we created that body, and we'll do the same shape binder. Let's pick this guy. Okay, didn't pick it correctly, so I'm going to, okay, so let's create that shape binder. Now I have the shape binder created. Now I want to actually translate, not here, I want to translate this shape binder in between these two fixed points. Okay, so even though this cross section changes, these two kind of origin points does not change. So if you measure them, let's say pick this point and this point, it's about, I don't know whether it is clear to you, but it's 20 inches. Okay, so I want to position this guy right in between these 2 points. Okay, so how do we do that? Okay, let's go and take this guy, let's transform it, say transform, so let's see, oh, I don't need to actually transform. What I'm going to do is I'm just going to, because this, you can pick this body and you can see there are axes and there are position dimensions given. So what I need to do is this y coordinates, just change the y coordinates here. So I'm going to say 10 inches. So it changed to 10, now it's in the right in the middle. And I need to also orient this, flip this over by 90 degrees. So I need to make sure that I pick the right coordinates where I need to rotate it. So this is, it has to be rotated about x. So I need to make this as a vector. X is 1, everything else has to be 0, so that it rotated about the x vector. And then I need to give an angle which is 90. So okay, voila, you got that rotated correctly. Now there is a little bit of issue here. How do I position this guy? Okay, now you can move it and align it, but you know, that's, if you try to do it just with a manual method and just put some numbers here, whenever you vary this will, you know, it will be 6th position, it will be in a fixed position, so you're going to have a problem. So that's what happened previously. So we need to tie this z coordinate of this section with the spreadsheet. Okay, so what is that z coordinate should be? So it should be the thickness times the half of the height of this section, or the inner section. Okay, half of this, so essentially half of this distance plus the thickness. So, and that can be embedded in our spreadsheet. So I'm going to say z coordinate of the section. Okay, gotta just put some words there, and now I have to create a formula for that. So I'm going to say equal, thickness is b2 plus the height, which is b4. So I'm going to say b4 divided by 2. Okay, that works. Okay, yeah, that works. Now this should be that section. Okay, now let's, so we have to assign a variable again. So let's put an alias here, say z code or something like, okay, maybe it didn't take it, so you need to be careful when you assign xyz. You need to make sure that you have a underscore connecting that, so that it is it has a proper acceptable variable for the Freecad. Now this is a variable, so you can go here, and this z coordinate now can be a variable, so it is driven by the spreadsheet. So that's z, so you can pick what you want and say yes. Now it is, you can see it is properly aligned, okay, with this section. So whenever this varies, this will vary, but it is going to be aligned with this the edge all the time, because we control it by a variable. Okay, so that's one aspect of it. So the second one is the length of this beam, that also needs to be controlled by the spreadsheet. Okay, so let's put another variable, can call it length of the beam, and it should be so let's say, so we know that total length is 20, right? So 20 minus and then you have to say, let me see what I got. So that should be the height plus 2 times the thickness. Okay, so that, let's see, I can maybe I need to redo this again. 20 minus, you put a open brackets, say b4 plus 2 times the thickness, which is b2. Okay, so I'm running into some issues here. Let's see what happens. This is, it has its problems. Okay, I know it's not, I don't know why this happens all the time. If it is doesn't do the first time, you may have to redo this again, or maybe, you know, may do it a couple of times until you get this correct. Okay, so that's okay. So I think the problem is, you have to, when you enter 20, it doesn't know what the unit is, so you have to give the unit as inch. Okay, so that's what the problem is. I kind of learned the hard way. And then you can say b4 plus 2 times thickness, which is b2. Okay, so that worked, right? Because the problem was that you have to define a unit. If you are working in millimeters, you don't have this problem, but if you're working in other than millimeters, you have to always enter the units. Okay, now then let's go here. Now I want to pad this section, so let's do the padding here. The way I want to pad this is, I want to say 2 dimensions. Now first of all, there's another small thing you have to do. This has to be half of this, that length has to be half of this. So I'm going to say 0.5 times the length of the beam. Okay, because it has to be half of each side. So okay, maybe, yeah, just trying to be like Excel, work like Excel, but it doesn't work that way. So let's say b12 times, or b12 divided by 2. Okay, so it's 8.9. Let's define or assign a variable to this, put an alias, so say, okay, half beam, something like that, beam. Okay, now so if we assign the variable, go here. Now I need to assign that variable to both of these. Okay, so once again, spreadsheet, then so half just type half and it'll show up. So okay, so that worked. Then do the same thing here, and then half. Okay, now say okay. So now you got that beam correctly defined. Now let's see what happens when I start changing this section properties, okay, or the section dimension. So I'm going to say 0.2. Okay, maybe that didn't work well. Okay, I need to go inches. Okay, that worked. And then I'm going to put a bigger dimension here. 8 inch, and I'm going to make this guy also make it big. Actually, I'm going to make it smaller, so just say 1 inch. So let's see what happens if I do that. Actually, I'm going to make it even smaller so that you can visually see what happened. Okay, now let's see what has happened. So you can see, yeah, it has changed. The section properties section has changed, and my beam, the cross beam, is pretty much aligned where I want it. It is not protruding into this the leg. No, it is moved wildly away from this section. It is aligned, the edge is properly aligned. Okay, so maybe I need to blow this thing off so that it's kind of obstructing the view, so you can see that. Now if I go and hide this and look at the section here, you can see the section is same as the section on that leg that we created, right? So I have achieved what I intend to do, and it was pretty simple using the spreadsheet, right? So I use few things in the spreadsheet, added few dimensions, and I got what I want out of that. So rather than trying to create it using constraints and all other stuff in this Freecad, which may not work. I tried a couple of times, that did not work, but spreadsheet was doing that pretty well. Okay, so that's something that I want to get to you guys, that you can start using the spreadsheet effectively. Now, since I have completed one section, I want to create another section, identical section, essentially a mirror image of this section to complete the stool. Okay, and then once you have these two sections, you can put some bench top, so that you can either sit, stand, or put some additional some other items on this stool. Okay, so the best way to do that is to do like a mirror image. Okay, so I'm going to go to part workbench to do this, and I'm going to pick the two bodies one after the other. And then how do you pick them is you would use the control key and pick the second body. Now both bodies have been picked. Go to mirror, and then now you can see both bodies has been picked, and I'm going to use the ZY plane, which is actually this one, which is called YZ plane. And then I'm going to give it an offset, some kind of offset. Let's say 10 inches, and say okay. Okay, so now I created the mirror image, and the distance between the two is actually not 10, it's 20 inches because it's a mirror, right? So I use the mirror 10 inches from this origin, such a way that I created a mirror image of this. So there's a separate body now created, this guy. And essentially it has its own mirror image. Okay, now Going a little bit further, I want to create another body which is kind of the bench top. So I'm going to go back to the part design. This is a pretty simple model, okay, so there's nothing controversial about this. Is more for trying to give you a feel for the spreadsheet. So I'm going to pick the one surface and maybe create a okay, say the independent copy. Yeah, that's what I want. Now I can create that bench top. So I'm not going to be very super precise here. That's not the purpose of this tutorial. It's just to get you guys accustomed to the spreadsheet. Okay, so I'm going to just create something here, put some dimensions. I don't even want to, maybe I'm not going to bother to constrain this even. Okay, put some dimensions and maybe I'll constrain it. Let's put something here. Okay, so got that. It's not super precise, but that's fine. And then you can pad this guy. So I think I want, like, let's say give it a, like a half an inch. Okay, so yeah, maybe give it a little bit more. 0.75. Okay, so so that's kind of what I want to get it as like a bench, kind of a contemporary look on that. And now we have the spreadsheet, so we're going to do a little bit more some kind of a design work. I'm going to put, let's say if I put some load here, what's the stresses going to be on these sections, and what are the limits that we can essentially there are going to be some limits how much load this can carry based on the section size. So we're going to explore that a little bit. So this is like a real design problem, and you essentially wants to optimize it such a way that this is light as possible, lower weight, and same time you meet the essentially it doesn't break, because it will have sufficient strength to carry the maximum load we anticipate that this bench is going to be designed to. Okay, now we are going to solve a design problem using Freecad. Okay, so now I'm going back into the spreadsheet. So in the spreadsheet, I have actually earlier had 6 decimal places. Now I have reduced to 3. Now how to do that is to pretty much go to preferences and then go to units, and you can increase or decrease the number of decimal places. That will take care of that. So since I have already done that, I'm going to cancel and exit. So everything is now reduced to 3 decimal places. So earlier case, I had information in this spreadsheet, certain amount of the information up to here. Now actually up to here. Now I have added few more dimensions and as well as some additional data, so in order to solve our problem. Okay, now one thing I have done is I added some weight, the maximum weight this the bench stool can carry. I said 400 pounds, and then also added a distance of 8 inches, And then okay, my yield strength of the material, I would probably call this more like a plasticky type material, so which has a very low strength. It's about 1200 psi, which is pounds per square inch. Oh, by the way, I can change the color here. I mean, I need to go to text color and change it to red. Okay. And then compressive stress, maximum compressive stress, this beams carry is about 1000 psi. So the beams are this one and this one. Okay, and then I have two sides to it. So when when you apply a load which is acting on this, if you put some weight on it or somebody sit on it, there's a weight going to be applied here, and then also distance, the weight is applied, which is a center of here, center of this plate. You can get a from one end to that, the load, or the point where the load is acting, it's about I said 8 inches in this spreadsheet. So that's that distance. Okay, now how do I calculate the compressive stress? I can do a force divided by area, which is represented here, F over A, and the bending stress formula is MC over I. You can get more details about this. You can Google them out and type MC over I, and then also type compressive stress, and you will get some more details about how these formulas are derived. Okay, and the MC over I, which stand for bending moment, is M, distance is C, and then your moment of inertia is I, which is also I will put in the video you will see some formula that shows as moment of inertia. Okay, now how, so we can all embed these formulas in the spreadsheet. Okay, so for I, which is the moment of inertia, I have already all the formula is typed in, and then on top of it, see, the cool thing about this Freecad is that you can give the units as well. So if you go here, I have embedded the units. If the units are not embedded, or if you don't put the units here, it will refer back to millimeters. So you have to be careful. You have to use the consistent units what you are working through the design problem. So in this situation, I have used inches, so I have used inch by 4 just to be consistent with units. Okay, so C is just the distance, which is to be the 1 inch is coming from, if you can see the formula, which is B6, and that is the distance to the outermost fiber of the section, the beam section, which is you divide this by 2, which is 1. So the moment is essentially you multiply the weight by distance, and since we have 2 sections, if you want to calculate the moment only on the one section, when I say 2 sections, one here and one here, so you have to take only the half of that. Okay, so that's why I divided by 2. So when I multiply, when I include all these into this formula, which is MC over I, which is based off of these B22, B21 divided by B20, you will get the bending stress, and of course compressive stress also you can calculate by dividing the weight by area. okay, and then divide it by 2 because you have 2 sections once again. So now you can see that my bending stress is actually above the yield stress. Okay, I want to make sure in this design my bending stress is less than 1200. Now how do I go and make that change? Only way I can do that is to change these design parameters, okay, and get a better or a bigger section that can carry a higher stress. So essentially, in other words, reducing the stress. Okay, so I'm going to do is I'm going to go and let's say increase the thickness. See what happens. So now my stress actually went down, but it is not lower than 1200, so I have to do something else. Maybe I go and change these to 0.2.5 inches. Still it's above, so I need to make a few more adjustments. So maybe I'm going to increase the width to 1.2 inch, and yeah, it's still high, so I'm going to make it like 1.3. Okay, so it is still higher, so you can play around. Maybe I'm going to increase this one by 2 inch. Okay, so now I got a section where I am able to the stress is reduced with respect to the yield stress. I'm within the margin or the limit, and both of them are within the limit. So you see, so that's how you solve a design problem using Freecad. And then same time what happens is your section here changes, so you have now a more robust section that can carry the load, maximum load that would be putting onto this bench. So that's kind of the tutorial, and I think you kind of learned it is not just CAD. When you use Freecad, you can use the spreadsheets to do some actual design and solve some design problem using you use appropriate units, and if you know the formulas of your your stresses and strains and all the design limits, you can use those information, put them into the Freecad spreadsheet and start doing solving an actual design problem. So this is what I want to get to you in this tutorial. I hope you learned something new. I haven't seen something like that in YouTube. So I hope you have learned something new, and please do leave comments and please subscribe. Thank you.